We're going to begin. This is the back side of this worksheet is where we have complex numbers. Here we go. And you know what? Even before trying any of these, we all know that the square root of 9 is 3i, right?
Yes.
Okay. The square root of negative 9 is 3i. I'm sorry. Yeah, that's right. The square root of negative 9 is 3i. Now, what I would like to do is not even go off of this worksheet. I'm just going to go to this blank part right here. And this is what you need to know. I is really I, obviously. Just like x is x, I squared is really, what is I really? Like, where does I come from? From the square root of negative 1, right? I comes from the square root of negative 1. So if I have I squared, what I really have is the square root of negative 1 squared. And we know that if you square a square root, what happens to that square root? It cancels. So what's your answer there? Negative 1. Does that make sense? Okay, so let's begin again. I equals I. I know you're thinking, why are you writing that? It doesn't make sense right now, but it will in a little bit. I squared is equal to negative 1. I to the third, I'm going to rewrite I to the third as I squared times 1 more I. Now, why would I do that? Because I already know that I squared is equal to negative 1. So this I squared right here is really equal to what? Negative 1. So what I really have here is negative 1 times I, and negative 1 times I is negative 1i, or just negative I. Okay, so I equals I squared equals negative 1, I to the third equals negative I to the fourth equals, how would I rewrite that? I to the fourth. I squared times I squared. That's exactly right, because it will be a negative 1 times a negative 1, right? We know that I squared is really negative 1, and we know I squared is really negative 1. So what's negative 1 times negative 1?
1.
Positive 1. And this is all you really need to do. Once you're able to write this out, you'll be able to answer I to any power, okay? Which are the ones you need to know for sure? You need to know the fact that I squared equals negative 1. Very important. I squared equals negative 1. You need to know that. Another important one is I to the fourth equals positive 1. That's a nice one to know also. Okay. So let's jump over here to the actual part of our worksheet. What's I squared again? Negative 1. Please memorize that. I squared is negative 1. So what's I to the third? It's negative I, because that's really a negative 1 times I, which is a negative I. Okay. How about I to the fourth? That's really 1, because I could rewrite it as I squared times I squared, which is really negative 1 times negative 1, which is positive 1. Okay. And I didn't show any of my work here. It's because we just covered it. But when we go up here to I to the fifth, in order for this to make sense to us all, I want to rewrite this as something that is nicer. I want to rewrite this as what? Anybody?
I to negative 1 times negative 1. I mean, you can do I times I4 times I1.
Okay, and there's many roads to the same place. You could say what you just said, Nathan. I squared times I, right? That'll give you I to the fifth. Or you could have used those 4 that we said. Where are we at? I'm lost.
So what would that be?
Right here. Yeah, we could use these 4 and use the I to the fourth, right? Because I to the fourth is 1. So I could have rewritten it as I to the fourth. So let me do this 2 totally different ways. I to the fourth times 1 more I, okay? So the first way, what do we get? We get a negative 1 times a negative 1. That's positive 1 times I. That's positive 1i, right?
Yep.
Let's go the other way, which should give us the same answer. What's I to the fourth according to those first four that we did? That's 1. And 1 times I is also I. Okay, so either way you do it, you're still going to get the same answer, I. How about I to the 8th?
I to the 4th times I to the 4th.
Yep, the explanation would be I to the 4th times I to the 4th. Now, why would I do that? Because I know that I to the 4th is what? 1. So you really have 1 times 1, which is 1. So this answer is 1. As a matter of fact, I might as well say this now. Any power that you could group in 4s, in other words, any power that's divisible by 4 is going to be the answer 1, right? Like if I said, what's, what happened there? Yeah. Like let's say, you don't have this on there, but let's say I said, what is I to the 12th power? Well, 12 is divisible by 4, which means I could go I to the 4th times I to the 4th times I to the 4th, which means I have 1 times 1 times 1, which is 1, right? Or if I had I to the, let's say, 36th power, well, that's I to the 4th times I to the 4th times I to the 4th. I mean, I don't want to do that. That's 9 of those, because 36 divided by 4 is 9. But there is no remainder, so I'll be able to group them all into I to the 4ths, which is going to ultimately be 1 times 1 times 1 times 1, which is going to be 1. Does that make sense? Yeah. So any power that's divisible by 4, like I to, what's I to the 40th? I to the 40th. That's going to be 1. What's I to the 80th? 1. Now, what if I had I to the 82nd? It's not 1, but think about this. 82 I's. You got 82 I's. If I group each of those into 4, I will have how many I's left over? 2 I's left over. So this problem right here is really the answer I squared, because you would have 2 I's left over. Does that make sense? So I squared is -1. So the answer to I to the 82 is -1. Again, I just wanted to throw these out at you. How about I to the 6th?
I to the 3rd times I to the 3rd.
Okay, I to the 3rd times I to the 3rd. You could do that, but when I look at I to the 3rd, I end up with a negative I. So I'd end up with a negative I times negative I, and it's still work to do. So why not write I to the 6th as something nicer than I to the 3rd times I to the 3rd? How about I to the 4th, which is 1, times I to the 2nd, which is -1? Isn't that nicer? You could have used I to the 3rd and I to the 3rd and done the math, but there's always a bunch of different roads to the same place, and obviously you want the shortest, quickest road. Unless you're bored, then go for it. But anyway, I to the 4th is 1 times I to the 2nd, that's -1. 1 times -1 is -1. There's your answer. How about I to the 10th? Yeah, you got 2 4s and 2 leftovers, right? So you got I to the 4th times I to the 4th times I to the 2nd. Or you could have said, if it's divisible by 4, you could have said I to the 8th times I to the 2nd. We know I to the 8th, or anything divisible by 4, that's just going to be a 1, right? Yeah. And 1 times this I squared, which is a -1, that's going to be -1 as your answer. I hope that makes sense. If it's not, please stop me. Nobody's stopping me. Okay. How about I to the 41?
I.
That's just I. How'd you do that?
Well, because 40 is divisible by 4.
Perfect.
You have 1 left over.
That's right. That's right. 40 is divisible by 4, and you need 1 more I to get to the power of 41. So yeah, I to the 40th, we know that is just 1, but times 1 more I to get to the 41 that you have here. So you really have 1 times I, which is just I. Pretty cool, right?
Yeah, absolutely.
Question? Any questions? No? Okay. Let's jump to up here, complex numbers. A complex number is a binomial, and the first number is the real part, and the second one is the imaginary part. You got 2 terms. First one's real, second one's imaginary. That's what a complex number is, okay? Now, we're going to be doing math operations with complex numbers. We're going to be doing math operations with imaginary numbers, which are complex numbers. do the same math as you would with x instead of I. The only difference is that if you ever have an I squared, you know that you should replace I squared with a -1. Yeah? Okay. So what is 3I times 2I? 6I squared. Now, what does that mean? I squared is really what? -1. So I really have, yeah, -6 as a final answer. Pretty cool, right?
Yeah.
So this section, honestly, is like pre-algebra stuff, right? All you got to remember is that if you have an I squared, change it to a -1, and then do any math possible after that. How about number 2? What's the answer there?
Oh, plus.
It's plus. It's not multiplying. It's not multiplying. 5 what?
5I.
5I. And that's it. It's the same thing as if it were 3x plus 2x. 3x plus 2x is 5x. Right here you got 3i plus 2i, it's 5i. The only thing you have to worry about is if you have I squared, put a negative.
Okay.
Right? But is that an I squared?
No.
No. Okay, we're good. Moving on. Well, back in pre-algebra, we would distribute. We're going to distribute here also. 3 times 4 is? 3 times 2i? 6i. There's no I squared. I don't need to worry about anything. And it is in order also. You want the real part first, the 12 first, then the imaginary part second. Let's go to this one over here. This one's a little bit more fun. We're distributing an imaginary. -3i times -5. That's like saying -3x times -5. Negative times a negative is a positive with an I.
9I.
Okay, what? -3i times -5 is positive 15 with an I, right?
Yeah.
Distribute -3i times positive 2i,
Oh,
-6i squared. But remember, I squared is really -1. So what you really have, yeah, positive 6. So you have the 15i minus 6 times -1. That's 15i plus 6. This is not the correct answer because it's out of order, right? Let's put the real part first, the imaginary part second. There's your correct answer right there.
I thought that was a 1. 21.
Ridiculously easy. Minus sign right there.
It's easy, you just need to learn the positioning where it goes.
If you understood Algebra 1, adding, subtracting, multiplying, you're going to do well on this. All you got to remember is that the I squared changed to a -1. So right here, you're distributing that minus sign. You got a -3. You got a -5i. There's nothing to distribute out here, so just rewrite it. You have 4 plus 2i. Now you got 4 terms. You could combine the like terms. Of course, you want the real number first, so let's do the real numbers. You got 4 minus 3. What do we get? 1. And then how about the imaginary numbers? We have a 2i minus 5i minus 3i. There you go. Final answer. Now we know it's not going to stay that easy though, right?
Yeah.
Okay, let's get to something a little bit more entertaining. You have a binomial times a binomial. So this requires some work. Let's do it. What's 1 times 3? 3. 1 times 3 is 4. 1 times 3 is 3. It's algebra 2, right? 1 times 4i. 4i. How about positive 2i times 3? Positive 6 with an I. How about positive 2i times positive 4i? Positive 8i squared, right? I squared. But what is I squared really? So check this out. I'm going to put a -1 right here and multiply it by that 8, giving me finally a -8 right there. And now what about the middle terms, the positive 4i and the positive 6i? I could actually combine those. Those are like terms. That's right. But first I'm combining the two middle terms, giving me a positive 10i, bringing down this 3. And now we have those 3 terms. And yes, we're going to combine the 3 with the -8. And when we combine 3 with -8, we get the real number -5. And then the imaginary part second, 10i. So we got the -5 combining the 3 with the -8. So there's your final answer, -5 plus 10i. Any questions? Do you guys remember yesterday when we multiplied a binomial by its conjugate?
Yeah.
What was a conjugate? It was the same binomial,
But different sign.
but different sign in the middle, right? Not opposites. You can't say opposites, because if you say opposites, that means that this 3 should be a negative 3 over here. It's just that middle sign, just the sign of the second term. That's what changes. That's it. And back when we were doing this, we would multiply a binomial by its conjugate, and the square roots would disappear. We get a nice, beautiful answer. Same situation here. When you multiply a binomial by its complex conjugate, everything cancels out. You get a nice, beautiful answer. How about, I want to pause this, try to do it, see who gets a beautiful answer. Distributing. 3 times 3 is 9. 3 times negative 2i is negative 6i. Positive 2i times 3 is a positive 6i. Positive 2i times negative 2i is a negative 4 with an I squared.
So it's plus 4.
Yeah, and of course, me showing my work here, the I squared becomes negative 1 times the negative 4. You end up with a plus 4 right here. And yes, the middle terms will eliminate in this case. And this 9, you're going to just bring it down, and 9 plus 4 is 13. The beautiful answer, 13, no more I's. So
I accidentally wrote negative 2i squared instead of 4.
okay, all right.
So that's my mistake.
So multiplying by the conjugate is a beautiful thing, right? Because it doesn't matter whether you have square roots or imaginary numbers. You cannot leave a square root in the denominator of a fraction. You can't leave an imaginary number in the denominator of a fraction. So if I had something like 2 over negative 1 minus the square root of 3, I can't leave that square root of 3 in the denominator. Okay?
It's comfortable.
You need to get rid of that square root. Now, how could you get rid of the square root in the denominator if you have a binomial? You'd have to multiply by its conjugate. So let me demonstrate that. Multiply this by its conjugate. What is the conjugate? Negative 1 plus square root of 3. Now, you can't just do something to the bottom of a fraction. That would change the whole thing. What you do to the bottom, you must do to the top. And doing the work here, 2 times negative 1 is negative 2. 2 times positive square root of 3 is positive 2 square root of 3. So that's a numerator. Down here, negative 1 times negative 1 is positive 1. Negative 1 times positive 3 is negative 1 times square root of 3 is negative square root of 3. And then we have negative square root of 3 times negative 1. That's a positive square root of 3. And negative square root of 3 times positive square root of 3 is a negative square root of 9, which ends up giving you just 3, right? So the middle terms eliminate. You have 1 minus, that is 3. So 1 minus 3 is negative 2. So up on top, we have the minus 2 plus 2 square roots of 3. And on the bottom, we have a minus 2. So that's our answer. But in this case, all 3 terms are divisible by 2, or better said, negative 2. If you divide by negative 2, that'll cancel out to be 1. Divide by negative 2, that'll cancel out to be 1. Divide by negative 2, that'll cancel out to be a negative 1. So what we end up with is a 1 minus the square root of 3. So that's the final answer there, 1 minus the square root of 3. I know that this was not on today's lesson, but it was a part of yesterday's lesson that we never actually did. We can't leave square roots in the denominator, okay? So hopefully we kind of understand that. Back to the worksheet. Let's practice stating the conjugate. What's the conjugate of number 1?
3 plus
3
2i.
plus 2i.
Yep. Conjugate of number 2?
5 minus i.
5 minus I. Conjugate of number 3?
Negative
Negative 3
3
plus 7i.
Yep. Conjugate of the last one?
Negative 2 minus 6i.
Only the middle sign changes. Now, once you know that, and this is what I say on the notes, just what I explained a little while ago, you don't want to leave an imaginary number or a square root in the denominator of a fraction. We must multiply both top and bottom by the conjugate of the denominator to get rid of both radicals and imaginary numbers. So on number 1, I don't want the I in the denominator. I need to get rid of that I. What am I going to multiply both top and bottom by?
By 1 minus 2i.
By the conjugate, 1 minus 2i. That's right. And what I do to the bottom, I do to the top, 1 minus 2i. I'm going to distribute. I end up with 3 minus 6i up on top. And on the bottom, I distribute 1 times 1 is 1. 1 times negative 2i is negative 2i. Positive 2i times 1 is a positive 2i. Positive 2i times negative 2i is a negative 4 with an I squared. With an I squared. So yeah, doing the work, that I squared becomes negative 1. You have the negative 4 times negative 1. That's a positive 4. We know that the middle terms eliminate when you multiply a binomial with its conjugate. And this one, we're just going to bring it down. 1 plus 4 is 5. So what we have here is a 5 right there. Now, that's my answer. However, we just said that a complex number, when you have real parts and imaginary parts, you want them separate. You don't want both of them together as a numerator. So what I'm going to do is take this 5 and split it to each of those. So my final answer will be 3/5 minus 6/5 with an I next to the 6/5. I just simply took the 5 and split it and put it both on the 3 and on the 6, and that's how I got these two fractions as answers. And it is important to split it, real part first, imaginary part second. So on all of these, it's pretty easy. You're going to multiply both top and bottom by the conjugate of what you see. However, you don't need to do that much work on number 4, because number 4, you don't have a binomial. Right? In the denominator, you don't have a real number out here in front. Like if it were a 7 minus 3i, yeah, I'd multiply by 7 plus 3i, 7 plus 3i. But there is no 7 minus 3i. It's just minus 3i. It's a single I. So if I wanted to get rid of that single I, all I would have to do is multiply by I, because I times I is I squared, and I end up with a negative sign. Right? So what I do to the bottom, I do to the top, multiply by I, and you will get rid of the I in the denominator. Okay? So on the bottom, I times I, that's I squared, so you really have negative 3 times I squared, but we know that I squared is really a negative 1, so what you really have is negative 3 times negative 1, which is really a positive 3 in the denominator. Now up on top over here, we have an I times 3, that's 3i. We have an I times I, that's an I squared. Wow, that's disgusting. Hold on a second. There. Because when I go from, okay, I'm sorry, let's just move on. What is I squared? Negative 1. So what I really have is negative 1, which is a real number. So that's going to go first. And then I have the positive 3i, which is the imaginary part. That's going to go second. And now, again, you don't want to leave it together as one fraction. You want to separate the real from the imaginary. So we're going to take this 3 and put it both on the 3 and on the negative 1. So what we have here is a negative 1/3 plus 3/3 with an I. But of course, that 3/3 could be reduced down to 1. So your final answer is negative 1/3 plus I. Make sense? Okay. How about you guys try number 2 right now? I want to pause it, and then we'll go through the explanation in a couple of minutes. Boom! The correct answer is 1/2 plus I. Let me walk you through this. When you distribute 5 times 2, you get 10. 5 times negative 4i, you get negative 20i. 2 times 2 is 4. 2 times 4i is 8i. Negative 4i times 2i is negative 8i. Negative 4i times positive 4i is negative 16i squared. Remember that I squared is a negative 1? So you have negative 16 times negative 1. That's a plus 16. Now the two middle terms, the 8i and the negative 8i, these guys cancel out. So you have the 4 that comes down with the plus 16, which gives you 20. And that's on the denominator of the fraction. And you got to split that 20 to both the 10 and the 20. That's why we have 10 over 20 and 20 over 20 with an I on the second one. And then you reduce both fractions. 10 over 20 reduces down to 1/2, and 20 over 20 becomes 1 with an I. So 1/2 plus 1I. If you got that right, you guys are awesome. Whoa, what is happening here? So I know that I need to multiply by the complex conjugate, which is minus 3 minus 2I. We do to the bottom, do to the top, minus 3 minus 2i. And of course, you have a binomial up on top. It's not just a regular number, it's a binomial. So you're going to have to distribute and combine like terms both on top and on the bottom. So up on top, 1 times negative 3 is negative 3. 1 times negative 2i is negative 2i. And then I go positive 2i times negative 3i. That's a negative 6i. And then positive 2i times negative 2i. Positive 2 times negative 2 is negative 4. But I times I is I squared, right? I times I is I squared. And we know that I squared is really a negative 1. So I really have a negative 4 times negative 1, which really gives me a positive 4 out here as my last term. Now when we look at the middle terms, the negative 2i and the positive 6i, that will combine together to give me a negative 8i. Negative 8i. And of course the minus 3, I'm just going to write it up here, minus 3. So what I really have is a minus 3 minus 8i plus 4. We could combine the two real numbers. What is negative 3 plus 4? 1. So I want to put the 1 right here because that's the first real part, 1, and then the minus 8i second. Okay, so that's the numerator of the fraction. Now let's work on the denominator. Let's again distribute negative 3 times negative 3, that's positive 9. Negative 3 times negative 2i is positive 6i. Positive 2i times negative 3, that's a negative 6i. Positive 2i times negative 2i, that's a negative 4. I times I is I squared. And we need to remember that I squared is really a negative 1. So I really have negative 4 times negative 1, which does give me what you said, Jesus, plus 4. We end up with the middle terms canceling out. And with this 9 just coming down in the front, and 9 plus 4 is 13. This is the denominator of our fraction, 13. Of course, whenever you have a real and an imaginary part, you want to split them. You don't want to leave them together as one single fraction. So we're going to take this 13 right here and split it both to the 1 and to the 8. So the final answer is 1 over 13 minus 8 over 13 with an I next to the second fraction. Whew, I'm done.